There are several factors that can affect the rate of reactions. The first one here is the temperature. At higher temperature, there will be faster rate of reactions, meaning that a shorter time is required to form a product in the reactions. Let's say when we have a system here where the system is supplied by heat. In the system, there are more particles that can absorb the heat in the form of energy. When the particles absorb the energy, there will be bond breaking among the particles, and this will result in the frequent collisions among the particles with greater intensity. Next, the second factor that can affect the rate of reactions is the concentration of reactants. At higher concentration of dissolved reactants, resulting in a faster rate of reactions. Let's say when we compare between two systems with the same amount of space but different in concentration, which is 0.2 molar and 10 molar, at higher concentration, which is the 10 molar, we'll have a more frequent collisions among the particles. But please bear in mind that as the reactions proceed or progress, the concentration will be decreased with time, meaning that the concentration are used up in the reactions to produce products, and the rate also will eventually become slower with time. The third factor is the pressure. At higher pressure can also be related to higher concentration, which will result in a faster rate of reactions. Let's say when we have system here where the system having a large volume, however when we are applying pressure to the system, we are forcing the gas molecules into a smaller volume, meaning that there will be a higher concentration of the gas molecules in the system, then there will be a frequent collisions among the particles and the reactions can proceed faster. Conversely, when we increase the volume of the system, the pressure will be decreased and thus will result in a decreasing of the collision frequency and then reduce the reaction rates. The fourth factor is the surface area. At higher surface area, there will be faster rate of reactions, meaning that the exposure of the surface of a solid reactant can influence the rate of reactions. Let's say here when we have a single large cube reactant, we consider this as small surface area. But when we maximize the surface area by crushing this large cube into pieces, there will be higher surface area. The smaller the pieces, the larger the surface area, meaning that there will be higher possibility of collisions among the reactants molecule and greater chance of reactions. The fifth factor is by the involvement of catalyst. Catalyst is a species that can speed up a chemical reactions without itself being consumed in the reactions, meaning that the mass or concentration of the catalyst is the same before and after the reaction takes place. And the catalyst is functioned to overcome the activation energy barrier. Let's say when we have an exothermic reactions here where the original activation energy, the blue one, is quite large without the presence of catalyst. However, when we add an appropriate amount of catalyst in the system, the activation energy is lower, meaning that the reactants or the system will have a sufficient kinetic energy to initiate the collisions among the particles and then increasing the rate of reactions.